Alright, starting with today, we are on lesson 8.2, apply exponent properties involving quotients. So this one looks like we're going to start looking at a little bit of like fractions with it, but it's really not too difficult. I actually feel like today's, even though division was easier than yesterday's, because yesterday's involved a lot of negatives that would mess people up. Make sure you have this. I still gotta give people Starbucks. I need people to like write something, so I'll do it. You don't have to get up now, we'll do it. So make sure you're using this because it is helpful review. Alright, so let's look at our warm-up. It says, evaluate the expression q to the third when q is 1/4. So remember, here's the easiest way. When I was looking at these and I'm making sure I'm doing them, one thing that helps me, especially with the fractions, is understanding what this means. When we put an exponent on, it means we're timesing the number by itself. So if I do q to the third power, and q is a fourth, that really means I'm doing 1/4 times 1/4 times 1/4. That is what that power to the 3 means. And then can we solve that? Well, that's pretty simple. 1 times 1 times 1 is 1. And 4 times 4 is 16. 16 times 4 is 64. So that is our final answer. Now, I did it the long way, and I just showed you what it really means. When we do q to the third power, it means 1/4 times 1/4, 1/4. Can you see a shortcut now? What probably this whole rule is going to be? Patty?
Fractions. It's just going to be like multiply line straight across, or like something you can do is just like put like each number, but just times it itself by 3.
Okay, don't times the number by its 3, but you're going to cube it. Mainly when we have a fraction, like 1/4, and I say to cube it, like this, or to the third power, instead of writing it out, 1/4 times 1/4, 1/4, you're going to see that it's going to mean this 1 is to the third power, and the 4 is to the third power. That exponent is getting distributed to each one, your numerator and your denominator. So, c squared when c equals 3/5. So, Evan, what do you think you should end up getting? Maya?
9/25.
You should get 9/25. You could have thought of this as 3 to the 5th times 3 to the 5th, since I have 2 of them, which is 9/25. Or, if I had 3 squared, 5 squared, I'd get 9/25. So today our goal is that I can simplify expressions involving quotients. Kind of what we're doing here. Alright, so if you look in your foldable, this little booklet thing that's magical, quotients of powers is where we're at. And we see in their example, they give me the example a over m, or a to the n power, and a to the n power if that base is the same, how a is the same on both of them, that we are going to be subtracting them. The base stays the same, and we have m to the n. Okay? Treat the division bar like a giant subtraction sign is what it said. I put a picture up that would kind of help, hopefully, that you can copy on mine if you want, where they use the real life example. So we want to keep the base, but we're going to subtract up here. What do you think on my example your answer is going to be? So we're going to keep the base as 8, Do you think we're going to say 8 to the negative 2 power? Well, we're going to learn about how we can. Because I think that's... Get my booklet out. In your booklet, look at the very next one that says negative. Katie's right. This would be like a negative 2 here. Or, here's an easy trick to learn. If I look at these two, and the bases were the same, the base on the bottom had the bigger exponent, right? So when I write my fraction, I'm going to write it as 1 over, and that base is going to stay, and it will keep the positive answer, the absolute value between 3 minus 5. I can either write this as 1 over 8 to the second power, or the next day we're going to learn that I could write it as this. We'll be okay. So, let's look at our example right here. Just to simplify this. A to the 5th power divided by a to the 3rd power. We have the exact same base. So I'm looking at a and a. So in my answer is going to be a. And we take our exponents, because we are dividing, we are going to be subtracting. The numerator, 5 minus the 3. Let me erase this so this get it all right. And 5 minus 3 would give us a to the 2nd power. That is your answer. So go ahead. I'm going to see if we're on the right track. Let's do just a together. If I look at this, we have the same base, 8. And then what would be my exponent? Ron, what do you think we do for our exponent? Okay, so you got 6. How did you get 6? Good. Your numerator's exponent, 10, minus your denominator's 10 minus 4. So at 8 to the 6th power is your answer. Okay, how about B? What's different on B? So how do I simplify my numerator first? My numerator should be what now? Ready?
8 to the 12th power? Or would you minus it?
Why'd you get 8 to the 12th power?
Oh, 5.
Okay.
I couldn't read it.
Okay, so we have the same base, and so we keep the same base. Should be 5, and 4 plus 8 was to the 12th power. You were right. So I'm simplifying. I have 5 to the 12th power, all over 5 to the 7th power. All right, Heckman, what do we do next? We use the subtraction. So I'd have same base, 12 minus 7, and it's simplified to what? 5 to the 5th power. So far, not too difficult, right? To be honest, I was kind of happy with today's. I thought it was a nice little break. We just have to take our time and make sure that we're simplifying everything correct and using all the other rules. On C, before we can solve it, we need to kind of simplify it. What's our next expression, do you think? Reagan, what do you got? Good. Because this is a whole number, it's like it's over 1. So we first simplify. 1 times x to the 6 is x to the 6th power and x to the 4th power. And then Alex, to solve this, what would you end up getting? X to the 2nd power. Good. So I did 6 minus 4, x to the 2nd power. How does those feel? Anything that we kind of got you confused on with those last 3? on C. We changed it to fraction because they did a fraction times the whole number. So at first we just wanted to put it together. So we did 1 over x to the 4th. We changed x to the 6th just so I could visually see it. Just put it over 1. All right. Use the power of quotient property. I'm going to zoom in and see if I can see this right. So I kind of discussed this on our warm-up. See if you guys can throw this out. What do you think this would be? X to the third all over y to the third. That's your answer. If you ever get confused why, just slow down and say, okay, I know my exponent means I'm times it by myself this many times. So this would have been x over y times x over y times x over y. I'd have 3 of those, so I'd have x to the third and y to the third. Well, B. Alex?
You take 7, you distribute the 2 exponent to the 7 and the x. You keep the negative, and you get 49 over x negative. Oh, x squared.
Okay.
You have to make it positive since the exponent is 2.
But then we would have to make this a positive because this was a 2. Here's how I would write it to start off with. Because this is a negative, I could have said negative 7 squared x squared. And remember, when we have a positive exponent, that is going to make this a positive number. Then I would have broke it down to 49 all over x squared. If you are confused whether it should be positive or negative, just write it out twice. It's negative 7 over x times negative 7 over x. Negative times a negative is a positive. X times x, well, x to the first, x to the second, is x to the second power. Okay. Let's go ahead and see how you guys can do. We're kind of incorporating the last 2 days' assignments into simplifying the fraction and then using today. So I'm going to pause, go ahead and do A and B, and then we'll come back together as a class and see how well we did. All right, let's start working through A. When we looked at A, the easiest thing to do first is start with just your numerator. So, just looking at my numerator, I had 4x squared, and we are going to the third power. What would that numerator end up being? What does that simplify to? Anna, what did you get for the numerator? What would you simplify it to?
4 to the power x to the 6th.
Good. 4 to the third, and then x, you multiply your exponents. So x to the 6th. All over. And if we look at our denominator now, your denominator would become what? What do we got? What would our denominator be?
5 to the third power and y to the third power.
Okay. Now, here's the question and kind of the answer all together. Do I have to simplify this at all? No. I can leave it like this. If you went ahead and made this 4 cubed is 64, x to the 6th. 5 cubed is 125, y cubed. I know my x to the 6th and y to the 3rd cannot simplify them. But if I look at 64 over 125, only look at 64 over 125, can we simplify those? If no, we just leave. That is our final answer. So I would take either one of these two. Looking at B, first thing we need to do is the exponents. The one right here, the 5. So, I want to rewrite my equation. This would have equal, what would this equation? A to the second power over B, what would that be rewritten as I put it to the 5th power? Who had it? We heard from Katie, what would you have got?
To the 5th power, I got 10 because I did 2 times 5.
Alright, so it would be A to the 10. And then what would be your denominator?
B to the 5th.
Okay, so B to the 5th. And then we're timesing it by 1 over 2A. And we want to take this one and we would want to simplify. This would be A to the 10th times 1 is just A to the 10th power. B times 2A to the 2nd power. What do you think your denominator is right now? Rahab, what would my denominator be?
2 to the 2nd power and then B to the 5th.
Good, and good job putting it in order. The ABC order. Okay, am I done with this one? How can I simplify? Or what am I simplifying? The A's. Good. That's exactly what we were looking at today. The A's right here. So, I have A to the 10th divided by A to the 2nd. I'm going to look at my work down here. That's like saying A to the 10th minus the 2. So I would get A to the 8th. So my final answer is going to be A to the 8th power all over 2B to the 5th power. Everyone kind of get that? Good. You guys still need that up there? Any questions on how we ended up with that? Any of the steps you did not understand? Good. All right. Last one. Find the missing exponent. Ooh. Yeah, it was supposed to be hard. How did you get 4 so fast and easy? What did you look for?
3 times 4 is 12. 2 times 4 is 8.
Okay.
I said that one
No, 2 to the power of 4 is 6.
So, what I look for, just so you guys know if you ever get one like these, look for one of the simpler ones that you can look. I looked for the D, and I just said, hey, if D is all by itself, and D goes to here, it has to be a 4. So then I just applied it here. Well, 2 to the 4th power, 2, 4, 8, 16. It works. It works. All right. Pretty good. Do you see the biggest thing I want you guys to be aware of? Today's assignment, the only new part was when we were talking about the division. Have the same base and then subtract your exponents. What else you're going to be doing is applying just like on this one where you're going to have to be applying some different rules that we've already learned. I think we should be okay. Your assignment, page 498, I thought it said 499. 498 through 499, 8 through 48 even. You can use the rest of class. We still have 5 minutes to start on your assignment. If you want to bring me, I'll pull them up and I'll just ask for your book that people are waiting for their Starbucks. And then if you have any questions over yesterday's homework, you can even ask today if you want. If not,